Hello, hello everyone. This is Texas Instrument Analog interview questions. These are the questions. There are five questions. This is first, second, third, fourth, and fifth. So let's start with first. So in first question, they ask to draw low pass filter and note its step response, and also they want to drive the relationship between V out and V in. So let's start the question. First of all, we have to first of all we have to understand about a low pass filter. What is low pass filter? Low pass filter low pass filter basically it pass the low frequency and attenuate the high frequency. Like if this is the high frequency response, high frequency input, it will attenuate this like this. And if this is the low frequency response, it will pass this low frequency response. So they want introvert one to introvert one a low pass filter, low pass RC filter. So this is the low pass RC filter. This is V out and this is V in 0 volts 1 volt. So let's discuss about step response, but step input. So this is the step response. This step response look like this, and this one, this one is high frequency input, and this part is low frequency input. So you can see that like a low pass filter has to attenuate this part and low pass has to pass this part. So how this is the infinite frequency, we can say like this. If we have an sinusoidal waveform with some frequency, let's say f, and we want to increase the frequency, and if we increase the frequency like this, then further increase the frequency, it will behave like this. So it's look like this part. So this is the infinite frequency. So any input, any signal which has infinite frequency look like this response, this input. So this is R and this is C. Now we can analyze the circuit with respect to t is equal to 0 in time domain. Let in time domain in t, if t is equal to 0, omega is equal to infinite like this. At this time, this is t is equal to t is equal to 0 time period. T is equal to 0 time period. Wait a minute. This is t is equal to 0 time period, and there is the frequency infinite at this time. And when t is equal to greater than 0 or t is equal to infinite time, omega is equal to 0. This part has 0 frequency. So and in t is equal to 0, omega in at sorry, not in at t is equal to 0, omega is equal to infinite. Omega is equal to infinite due to this capacitance. So because impedance of C depends upon frequency, like this omega sorry SC. So if omega is equal to infinite, impedance 0, so capacitor soft. So circuit behave like this. Circuit behave like this. Sorry, it will connect to ground directly. It will connect directly to ground, and all the 0 appears to V out. So V out is equal to 0. We can say this at t is equal to 0. At t is equal to infinite, omega is equal to 0, or t is equal to infinite, or we can say t greater than 0, omega is 0. So when omega is 0, impedance of capacitor becomes infinite. So circuit behave like this as open circuit, and this is input plus minus in, this is input. So all the input appears to appears on V out. Because so so V out, all the V input appears to be on V out. So V naught is equals to V out. And we can also calculate the time constant for this circuit. For time constant, we have to time constant we to uh, we have to shut down the input. We time constant we have to close or shut down whatever code shut down input or independent sources independent sources. So this is the circuit, and we have to close or remove the independent input source, and for a time constant we have to see R equivalent and C equivalent. How can we see this? Like for R equivalent we have to see from the capacitance perspective, like with respect to this capacitor, what is R equivalent? So with respect to this capacitor, R equivalent is R, like this. With respect to this capacitor, so R equivalent is equals to R, and with respect to R, with respect to resistor, C equivalent is C. Like we can see this with respect to R, C equivalent is C. So our time constant is R C. How is R C? This is R C, and we can now we can plot the waveform for the input. Uh, so this is input step response, and t is equal to 0 time period, and this is time axis V out. This is V input. This is the input put, and now we have to draw the waveform. Like at t is equals to 0, V out is also 0, and t is equals to infinite, like t is equals to infinite, output becomes V out. So this is output, and uh, in between graph look like this exponential graph with time constant RC. So this is the step response. Now interviewer also want us to draw the relationship between V out and V in. This is like an intuitive explanation of this circuit, and now we can also prove this in intuitive way. Sorry, mathematical way. Like for mathematical proof, like we have to make an circuit again. This is resistor, this is capacitor, and this is the input. This is the like we have to apply KVL, Kirchhoff voltage law. This is R, this is C. So V input is equals to VR drop across R and plus VC drop across C. So V input is and V input and VR is like this is IT current. This IT current also flows into capacitor IT. So VR becomes ITR, and VC becomes like for capacitor, and in capacitor equation I and Q is equals to CV. This is the charge equation. If we want an current equation, we have to differentiate this charge equation like with respect to time. So we get IT cause dq by dt is current and C capacitor is constant. So this is the voltage equation. V in is equal to VR plus VC. So we can write this is current IT. We can write it is ITR. This is voltage drop across the resistor plus VC plus VC. VC is also write as V out. We can write this as V out. Okay, and for the I like Q is equals to C. This is the charge. This is charge equation. Charge equation of capacitor. Charge equation of capacitor and this is charge equation of CV. We have to differentiate it and we get IT is equal to C dV by dt. In this V is the capacitor voltage. We can also write it as the V out. We know dt. We know this is V out, I guess. Yeah. So IT is this, and we can write this IT as C d V naught by dt plus V out, and this is okay, and this is V in equation. Now we can see this becomes like an becomes like an a linear differential equation, like in the form of what we can say this is some constant a1 dy by dx plus y is equal to, and this is qx function, this is yx function. So this is y, this is qx function, like this. This is this and this behave like this. This is a linear differential equation. If we solve this equation, then we get result as v out is equals to v in 1 minus e minus t rc, t into rc. This is not like an rocket science. You can also solve by yourself. This is linear differential equation. If we solve this, we get this equation. So this is a charging equation of capacitor. This is the input 1 minus e minus t rc. This rc is time constant. We can also write this as tau v out actually. So this is the final answer for this question. This is good form, and we give each and every explanation you need for this question. Now in question number second, we can see this is an high pass filter. Like we can see this by orientation of capacitor and resistor. So in this question we were given an pulse of 1 hertz and asked to plot V out versus V input. Like we can solve this easily. So for this, first of all, we have to find out what is the time period of this pulse. Because all the answer for this question depends upon this time period and time constant, like tau for this circuit. And first of all, we find out the time period of this pulse. For this pulse time period, so time period is inversely proportional to frequency. So time period is 1 upon like like 1 upon 1, like 1 second. So time period is 1 second, and tau is R equivalent and C equivalent. We can find out tau. Tau is 10 into 1 microfarad, and if we solve, we will get this 10 and 10 minus 5 second, like is 2 millisecond. Like we can see we can see this, the time constant is much smaller than the time period of a pulse. So this is a good sign. Suppose this type of question is easier to solve. Suppose the charging and discharging of cap is rapid. Rapid means like charging and discharging of capacity is rapid. It's not depend upon no more depend upon pulse time period. Like if the time constant is greater than time period, then we have to see when the capacitor charge, it will charge before the positive pulse, or after it will charge fully before the positive pulse, or it will charge midway through positive pulse. Like it's so unpredictable. We have to consider each and every case. Like if a capacitor charge up to this, not fully charged, like when a positive pulse occurs and capacitor charge at this point. So in next cycle, when pulse is zero, capacitor has to discharge, and it will not discharge to zero. It will discharge somewhere that position, and then now a new pulse comes, and then capacitor charge. And we can't say at what value capacitor charge simply. Like we can say at what value capacitor will charge by equation, and solving the question. It will become quite difficult. So this that's why this type of question are difficult. Not difficult, more complicated to solve. We have to include the equation like charging for capacitor equation, then the charging capacitor equation, then we have to solve. So then we have to find out the more accurate value. Okay. So but for this time we have to focus on tau less than t. So in this type of question, the capacitor in the charging and discharging of capacitor is rapid, like this. If this is a pulse, then we don't have to worry about when the capacitor will charge at this point, this point, this point, this point. At what point the capacitor will charge instantly, and it will charge fully at positive pulse, like this. And if capacitor has to charge, it will discharge fully. So we can say for sure the capacitor final value is like 5 volt if this pulse input pulse is 5 volt. In this case, maybe it's an 1 volt, so we can say that capacitor will charge up to 1 volt, then discharge to 0 volt. That's why this type of question is easy. So we can say in this type the capacitor will charge up to 5 volt, or sorry, 1 volt or 0 volt instantly. This is the meaning of tau less than t. Okay. Now now we solve this question. Like for this, sorry for bad handwriting, I'm new to this. And for positive pulse, uh, positive half pulse, like if we consider this at this time frame, like at t is equals to 0, t is equals to 0, at t is equals to 0, t is equal to 0, omega is infinite, cap shorts, circuit reduces to this V out. This is the input, and we can see all the V input travels to V out. So V out becomes V in. This is the definition of high pass filter, which pass the high frequency, like infinite frequency. This which pass the high frequency and attenuate the low frequency. This is low frequency input. This is high frequency input. So at t is equal to 0, it pass the high frequency, like V out, V naught is equal to input. Okay, and this is R. And at t is equals to greater than 0, not not infinite, because this is an a pulse response, we can say less than uh, t on. Like I am marking this time period as t on, and this time period is t off, like in duty cycle. So less than t on, we can say. So this time frame, the at this time frame is at this time frame we can say, at this time frame we can say at this time, sorry for repeating. At this time we can say input is constant, so frequency is zero. Due to this cap opens, due to this cap opens, and the circuit behave like this, and circuit behave like, sorry. So this is a capacitor. A capacitor becomes open. Now for this capacitor become opens for this time period, and this is input. So all the, and we can say all the in drop across capacitor, like what are happening at this time t is equal to 0 second, whenever at omega is equal to t is equal to 0 and omega is infinite, capacitor short. So all the input appears to this resistor, and there is a constant, sorry, step current, we can say, for a moment there is step current for a moment, like we in by this is an step current. It is not a constant current, because this is not a constant current, it's an instantly and a step current, we can say as an instant current. So there is an current, and when we say t greater than 0, this current is flowing into capacitor. This current flow into this capacitor, like this capacitor, and whenever the current entering the capacitor will charge. Then it's not a constant current, as we can say, we are saying, cause whenever this capacitor charge, then voltage across this capacitor changes due to this current changes. Okay, so it's not a constant current, and not a constant current, and slowly capacitor will charge, and at some time period, capacitor charge fully. Okay, so when capacitor charge fully, it becomes an open circuit. It becomes an open circuit and capacitor charges fully. So whenever capacitor charge fully and it becomes an open circuit, and all the voltage drop across this capacitor like V, and all this ground voltage appears on V naught. So at t greater than 0 and less than t1, V naught becomes 0. It will attenuate the low frequency response. And for the like we see, sorry, like we cover the circuit for this half pulse, and for another half, at another half the input in becomes 0. So now the circuit look like this. This is capacitor, this is resistor, this is ground, this is V naught, and this is also ground. So pulse becomes 0, means it's at a 0 potential, so it's ground. And at this moment capacitor is fully charged, like plus minus V input. So all this V input appears to V out. So V out becomes minus V in for this moment. So it's this part is also an infinite frequency response. So a high pass filter pass this response and attenuate this, pass this input and attenuate this this input. Okay, so this is an also an infinite frequency response. So V naught is V in. Now when t greater than t on, like we are in t of period time, we are in t of range. So capacitor now starts discharging like this. Capacitor now starts discharging through this resistor. So slowly capacitor's voltage dies out, and this is an instant process. This is an instant process, cause tau is less than t. Okay, so we can see this on waveform like this is pulse. So and let me draw with another pen. So for high frequency, for high frequency, this is like and this will be like this, and for low, for this time period, it will be like this. This is V in, and this is minus V in. So it will like this. Okay, it will like. Now this is the most easiest question can say. In this question, there is some resistors, and we have to find the potential on A, B, and C node. So see this carefully. Like this branch is completely separate. Don't confuse this ground this ground symbol, as this ground symbol is not connected to this point. That's why this question is little bit tricky, because many people will thought like this is ground, so this is also ground, and they will connect they will assume and connect like they will assume like this, and solve circuit by KVL KCL and find and completely form some complex equations, then find out the potential on A, B, and C. So this is totally wrong. We have to do we have to think properly and do simple things. Like if if interviewer will say like this is also wrong, then we can say like this is connected. So we can form the circuit as like this, but this is not connected, so this part is separate and this part is also separate. So when the current I flows from this 5 volt source, it will circulate in this loop, not in this loop. So this is an separate branch. Like we can also remove this, because no current is flowing through this branch. Mm, no current is flowing through this branch. Okay, so it's like an voltage divider. It's like a voltage divider. In this is resistor. This is also a resistor. This is lowest potential. This is highest potential 5 volt. This is 1 ohm, good ohm, and we have to find out the voltage at this node. This is B. So both resistors are same. Both resistors are same, and this is node A. This is node B, and this is node C. Both are both are same resistor. It's like can voltage divided. So B voltage is 2.5 volt. 2.5 volt. A is 5 volt, and C at lowest potential, so 0 volt. We can see. Okay. So these last two questions are little bit tricky. In this interview, give this question, and he asked to plot between VA and VI. This is VA and this is VI, and find out the region of operation of the MOSFET. So first of all, we have to find out what type of MOSFET is this, and we can also say this easily like it's an NMOS. NMOS has this symbol. This is gate, and lowest potential one is source, and highest potential one is drain. So this at, so at this symbol this symbol is source, and this is drain. So this one is source, this one is drain, and this one is gate. So for MOSFET to be on, MOSFET to be on, for MOSFET to be on, VGS greater than V threshold. Okay. Also in the question, V threshold is, sorry, I didn't mention in the question, V threshold also is 1. It's an given. It's a given quantity by interval. So given value by interval. So VGS is greater than VTH for MOSFET to be on, and for MOSFET to be in triode region, like in triode region MOSFET will like a resistor. In triode region MOSFET uh, condition is VDS less than VGS minus VTH, na? And in saturation region MOSFET MOSFET condition is VDS greater than VGS minus VTH. So for MOSFET to be on, VGS is greater than VTH, and we can see VG is V gate at 5 volt, and source is VA, like it will greater than V threshold, and V threshold is 1 volt. So we solve at 5 minus 1 greater than VA. So VA always less than 4 volt. For MOSFET to be on, VA always has to be less than 4 volt. Okay. And for MOSFET to be in saturation region. For MOSFET to be in saturation region, so in triode region or in saturation region, we can solve any of these equation. We find triode and saturation region. So Vs and Vs will cut down. So it's on the same side, like Vd minus Vs, Vg minus Vs. So it will cancel out Vth. So equation like this: Vds less than Vg minus Vth, and Vd is V drain is V input. V input less than, or Vg is minus 5, 5 minus 1. So V input will be V input also less than 4 for triode region, and for saturation will be greater than 4 volt. So these are the conditions to be MOSFET to be on. MOSFET in triode region. For triode region, MOSFET always less than 4 volt, and for saturation region, MOSFET is always on the MOSFET always sorry, for MOSFET to be on, VA is less than 4 volt. For MOSFET to be in triode region, the input is less than 4 volt. It's not depend upon VA. And for saturation region, V input always must be greater than 4 volt. So if we put this on in the graph like this, sorry, if we put this on the graph, this is VA, this is VI. Okay, so for MOSFET to be on, VA is always less than 4 volt. So this is 4 volt. So in this condition, in this triode and in triode in saturation region, MOSFET is always beyond. So MOSFET will not. So VA will not increase beyond 4 volt. And for triode region, V input is 4 volt. Sorry, for triode region, V input is less than 4 volt. So it will become like this. Okay, wait. It will increase like this, and when VA reach 4 volt, it will become constant. And this region is saturation, and this is triode. And beyond V is cutoff region. Okay, so this is the final answer. So this is the input given. This is a pulse input from 2 volt to minus 2 volt. Interval asks us to find V naught. This is the last question asked by the interviewer, and let uh, let's solve for positive pulse 2 volt. Like this is an 2 volt. If we assume if we use an open circuit for diode, so this diode is polarized, because if we open circuit the diode, this potential is positive at high volt, because this is 2 volt gain because of this V input, and due to virtual short or virtual ground, this potential becomes zero. So this diode will conduct. So this will become like this, and the diode is zero. V forward voltage, V forward drop for diode is 0.7. So this will behave like this. Goes to op amp. It's an virtual ground. And now for this part, if you consider this voltage to be positive and this is zero, so people will say people if you consider this voltage to be positive and this is zero, cause virtual ground, and people might say if we apply an open circuit test, people might say this diode will be on, but it's not correct, because if you see current will flow in this direction, and this is in high impedance zone, so current won't flow in op amp, it will flow like this. So if we current change this path, it will not go in this diode, because this is an reverse bias diode. Current will not flow from this to this side to this side. This is the correct orientation for the diode. So current will flow. So current will flow in this direction. So this diode is on. So we can say this is point 0.7. Now this is V out. So for this path, so we correct, this voltage will cannot be positive. This is negative voltage. So if this is negative, this is zero. So this diode will conduct. So we can say intuitively, like for positive pulse, for positive pulse this way out is negative. Okay. So this is 1 ohm resistor. This is 2 ohm resistor. This is 0.7 volt. It is 0.7 volt. Now we have to find the current in this branch. This is 2 volt, this is 0.7 volt, this is 0 volt. We can find out the current, like current is 2 minus 0.7 by 1 by 1 is equals to 1.3 ampere, right? 1.3 ampere. Okay, so current is 1.3 ampere. 1.3 ampere current is found in this branch. So also 1.3 ampere also found in this branch. So for this branch, we will apply an KVL in this branch. So this is on 0 volt minus 2 into 1.3 and this is to positive to negative, means minus zero point 0.7 is equals to V naught. If we solve this, V naught is appears to be minus 3.3 volt. Okay, and for the negative half cycle, V in will become minus 2 volt, V in will become minus 2 volt, and circuit will become like this. This is an resistor, and now now at this time, this diode will conduct. Low diode will conduct, because if we apply open circuit, this is negative potential, and this is at positive potential. So this diode will conduct, and this diode will be off, and this diode will be off. Same logic like before. Okay. So we move to the now now the, now, so now this this diode and this diode will be on. Okay, no, sorry, not this one, not this one. Now lower diode will be conduct because this is at a lower potential and this is at higher potential. So this is minus no, this is zero point 0.7 volt, this is 0.7 volt, and this is op amp minus plus virtual short due to virtual short. This is V0. Now, now current will flow, current flow in this direction. This is at 0 volt. So in this path apply KVL. Okay, like X and 0 volt, higher to lower, so minus zero point 0.7 volt current will flow in direction, so I is equals to minus 2 volt. So I will becomes 1.3 ampere for this case. Now if we apply an KVL there at this, at we apply KVL at this point. Okay, so V note becomes V note V note minus zero point 0.7 volt minus 2 into 1.3 ampere equals to 0. So if we solve, we get answer as 3.3 volt. So for negative half cycle we get 3.3 volt as an output, and for positive pulse we get minus 3.3 volt as an output. So this is the final answer of this question, and this is all the answer for all 5 questions. Hope you like it. This is my first video. I will definitely improve in my next videos, and I will bring many more questions for analog and electronics only. Analog electronics, like projects. I'm thinking of doing many projects for in analog domain for simulation based using Cadence. If time will right, I will do these all projects. It will help my knowledge also, and your also. And I will definitely solve more analog question, analog interview mainly question. Also, I will explain some analog concepts, and definitely um, so I will solve analog interview question, mainly analog, also written test question, some projects, and I will also make videos on hardware implementation. Okay, so thank you for this. I will definitely make videos on this topic, and this was my first video. So if if I if I go somewhere wrong, please definitely DM, definitely comment on my video and tell how can I improve. Okay, I will definitely improve my speaking skills also. This is my vision for this channel, like projects on Cadence, analog interview question, analog written questions, some analog concepts, or also hardware based implementation like microcontroller based, or some analog circuit like DC converter. Also, I have plenty of experience. Also, I have experience in PCB fabrication. So, Bandhika's channel, I will definitely make videos on this topic in future. Thank you.